Welcome to this Nordic Semiconductor webinar. I'm very happy that you are all here to meet the nRF5340, the next generation in IoT. So I am your host today. My name is Petter Myhre and I work as a product marketing manager for Nordic Semiconductor. I've been with Nordic for almost 7 years. I started in the technical support team, helping customers with their wireless applications. Now I'm a part of product marketing, promoting Nordic's products and technologies, both on the cellular IoT side and on the short-range wireless side, with Bluetooth Low Energy, Bluetooth Mesh, Thread and Zigbee products. That's enough about me. Then I just want to go through some practicalities for this webinar. So the duration will be approximately 50-60 minutes. Questions are encouraged, so just use the top of the right sidebar to put in your questions. These will be treated anonymously, but if you type something in the chat, your name will appear. Towards the end, I will answer the questions. And if you have more questions or if your question wasn't answered in the way you wanted, please use TrustZone and put in your question there and you will get good answers. A recording of the webinar will be available together with the presentation at webinars.nordicsemi.com. So here's an overview of what I will present today. So I will first go through an overview and highlights of the product itself, the nRF5340. Then I will talk a bit about the markets and applications where this product can be used. We'll explain the hardware architecture and the hardware feature set, and also the software architecture and the software support that we have for this device. I will go into detail on the security features it offers and also the available development tools that you can use. Then we will have the live Q&A session in the end. So it's been more than 4 years since we launched the nRF52 series, or the first device in the nRF52 series, the nRF52832. Since then, this platform has been enhanced many times with larger devices with more memory and features, like the 52833 and the nRF52840, and also with the smaller devices like 52811 and 52810. Now it's time to do something new, and that's why I'm extremely glad that you are all here to meet our new flagship SoC, the nRF5340. This is a dual-core Bluetooth 5.2 SoC supporting Bluetooth Low Energy, Bluetooth Mesh, NFC, Thread and Zigbee. It brings all the great features from nRF52 series that we all know and love, while also adding many more features. The nRF5340 is our first multi-core device on the short-range wireless side, opening up many new possibilities when it comes to flexibility and performance and efficiency. A specific piece of code can run very efficiently or very fast depending on its requirements. It's a truly secure SoC, taking security to the next level by supporting trusted execution, root of trust, and secure key storage. It's an all-in-one device, so it takes all the great features from the nRF52 series, the Bluetooth 5.2 support, Thread and Zigbee. It's capable of doing operate in 105 degrees, and can do the extended supply range, 1.7 to 5.5 volt. but it's also adding more performance, efficiency, and higher integration, while also minimizing the power consumption. So here we have an overview of the SoC. It has a high performance application processor that can run up to 128 MHz. It's an Arm Cortex M33, so the latest and greatest from Arm. It has 1 meg of flash and half a meg of RAM. Then we have a fully programmable ultra-low power network processor, and this is a bit untypical compared to the other products in the market, because typically the network processor can only be programmed with some specific images. But in the 5340, both cores are fully programmable. You can put whatever code you want on them, and this makes it very flexible. I'll come back to the benefits of that later. The network processor also have 256K of flash and 64K of RAM. And it contains the Multiprotocol 2.4 GHz radio, which is completely redesigned. So it supports the same protocols, and it has a similar interface as before. So it will be very, very familiar if you are used to the nRF52 series. But it is redesigned, and the improvements go mainly on improved sensitivity and significantly lower power consumption. It also supports the supply range of 1.7 to 5.5 volts, so you can power it from rechargeable batteries or by USB. And it's qualified for operating up to 105 degrees Celsius, so you can use it in commercial and industrial applications requiring operation at higher temperatures. Typically, when you design a core, you have a trade-off between performance and efficiency. But since we have 2 cores, we selected to optimize one for performance and one for efficiency, so that when you design your product, you don't have to do a trade-off here. You can run the code that needs to be efficient in the network core, and the code that needs high performance in the application core. It also offers separation of concerns. So most wireless embedded devices have real-time requirements. The radio has to follow the timing required by the wireless protocol. Interfaces may drive a display or a motor. On one core, this could be difficult to implement and can often lead to compromises that you don't want to do. With nRF5340, you can let the network core handle the real-time requirements of the wireless protocol, while the application processor can handle the rest. So we have a multi-protocol radio, as you know. This is Bluetooth 5.2 and beyond. And we can say this because we are part of the Bluetooth SIG working groups. So we know what is coming, but this information is confidential, so we cannot talk about it, but we can design our devices so that they support the coming features. So it of course supports all the Bluetooth the features that was introduced in Bluetooth 5, the high-speed 2 megabit per second, long range and advertising extensions, and also direction finding, angle of arrival, angle of departure, and all roles in these setups. It supports Bluetooth Mesh and also supports Thread and Zigbee using the 802.15.4 protocol. So if we compare the 5340 with the nRF52840, our largest device in the 52 family, the TX current is actually reduced with 30%, down to 3.2 milliamps. And if you look at the RX current, that is reduced with 40%, down to 2.6 milliamps. And we have a sensitivity on the receiver for minus 97.5 dBm. And this is actually 2.5 dB better sensitivity than the 52840. And this means that you get 2.5 dB better sensitivity for 40% less current in receive. And this is very impressive. On the 52 series, you have 4 dB resolution of TX power, but on this device you have 1 dB resolution. So that you can very finely tune this output power. And this is very beneficial when you want to use it together with an external PA and you want to stay be within the regulatory limits in the specific regions that you want to use your device. Because you might have some variation on the TX power and you want to tune it so that it is as close as possible to the regulatory limits, but not above. It's a truly secure SoC. It offers trusted execution with the Arm TrustZone, so that you divide the flash, RAM, GPIOs, and peripherals into secure and non-secure. You have the state-of-the-art Arm CryptoCell 312. This is an upgrade from the 310 that we are using on the other devices. And this offers advanced hardware-accelerated cryptography. And together with the key management unit, this offers a root of trust and secure key storage. It's an all-in-one SoC, so it takes the most prominent features from the nRF52 series and puts it into one package. Supports Bluetooth 5.2, Thread, Zigbee. It has CryptoCell, it has USB, it has Quad SPI, high-speed SPI, and it has the extended supply voltage and also can operate up to 105 degrees Celsius. But it also adds more performance, more memory, high level of integration while minimizing power consumption. It is actually a Swiss Army knife. It can be used for anything. But there are some markets and applications I would like to talk more about. So what can this device be used for? So the first one I want to point out are the advanced wearables. So you have this high performance 128 MHz processor with DSP instructions and floating point capabilities. And this is very useful when you get all the data and computation you have to do on a wireless device and you want to have one chip that is able to do everything you need. It has half meg of on-chip RAM for data and sensor fusion. If you want more memory, either if you want to have program code running from the external memory or you want to save some you need external memory for saving data or fonts for a display, for example, you can use the encrypted QSPI for doing this. And this runs up to 96 MHz. You also have a 32 MHz high-speed SPI for displays and fast sensors. And you can do this sensor collection in the application or a network core, depending on what kind of bandwidth you need on the sensor. We will also offer a compact CSP package with very few external components, but we'll first release the QFN package. Then we have the professional lighting and industrial applications. And many of these actually have requirements that it will have to be operational at 105 degrees Celsius. The device supports concurrent Bluetooth LE, low energy, and Bluetooth mesh thread and Zigbee. And in lighting, for example, you would use one of the mesh technologies to control the light, but you can also run Bluetooth Low Energy concurrently, and this enables, for example, a smartphone to provision or commission and configure and control these mesh nodes, which is very nice in many use cases. It also supports Bluetooth direction finding and is more than capable of doing all the angle of arrival and angle of departure roles. And a very interesting use case is to combine the lighting system with a real-time locating system. Advanced security is required for the professional market, and the dual-core architecture here might not be needed for pure lighting control, but if you want to do something more, this is and this is typically where the value lies. It is very, very useful. And this is what we call property tech, adding sensors and leveraging the mesh network for data transfer for all kinds of applications. It can be room monitoring, space utilization, asset tracking. It can be wayfinding, guiding patients and visitors in a hospital, for example, or predictive maintenance by monitoring expensive equipment. Smart home have many of the same requirements as the industrial space. Here it's also designed for 105 degrees is beneficial. You can run Bluetooth LE concurrently with mesh technologies, as I mentioned. You have quite high performance and memory requirements. For example, for a door lock, the manufacturer typically wants to support many of the home ecosystems. So it wants to support Apple HomeKit, Google Home, Amazon Alexa Smart Home, and all of these, they are different. They use different protocols and they use different application protocols and commissioning schemes and so on. And all of this you need to have code in your product for. And this is eating up memory. And also the advanced security features are beneficial in these types of application. Of course, with the door lock as a good example. Healthcare and medical. Here you can also have real-time requirements. So it's nice that the user application runs in the application processor and the wireless protocol is maintained in the network processor. Both cores are programmable, as I said, and this enables you to do two-way supervision. This means that the cores can monitor each other, and if something goes wrong, it can take the appropriate action, for example, resetting the device. And it's also a focus on certifications. So if you want to certify a wireless protocol, for example, on the medical side, you can do this in a contained core on the network core, and then you can develop your application in the application core without affecting what's going on in the network core, and keep the certification. Advanced security features are also important in this space. You don't want medical information to leak out. And on picture here you have a insulin injection monitoring and recording device actually. Then we have asset tracking. RTLS stands for real-time locating system. And you have an illustration here. This can be implemented using the angle of arrival method. The angle is typically calculated in the locators, and if you want to calculate the angle of many tags, you need quite a lot of processing power and memory, which the nRF5340 provides. So let's get into the details. So as you can see here, you have a complete overview of the SoC with power and clock, application core or processor, and application or network core. So you can see that both of them are Cortex M33, but the application processor can run at either 64 or 128 MHz. It has DSP, floating point unit, and supports TrustZone, while on the network processor it is a 64 MHz Arm Cortex M33 without these features. To communicate between the cores, you use this IPC, inter-processor communication, and also a bridge between the cores is also available. The advanced security features are on the application core. So here you can see the CryptoCell, the system partitioning unit, and also the key management unit. While on the network processor, you have the peripherals for doing 128-bit AES that is typically required by Bluetooth Low Energy, for example, when you use the radio. When it comes to peripherals, the advanced peripherals are on the application core. So you have a USB here, quad SPI, high-speed SPI. You also have a total of 4 UART SPIs and 2 wires. And you also see the audio-related interfaces here, I2S and PDM. You have 4 PVMs, and also the NFC is here. On the network core, you have 1 UART SPI or 2-wire, and all these analog peripherals are also in the application core. The ADC, low power comparator, and the comparator. Then you can see here it's a shared 48-pin crossbar. So it has 48 pins or GPIOs in total, and these are shared between the 2 cores. Application processor, high performance with DSP and floating point instructions. And you can configure this to run at 128 MHz or 64 MHz, and it uses voltage frequency scaling. And this means that when you change the frequency, the internal voltage is also changed, optimizing for power efficiency. And it's optimized for performance, and you can actually get 510 core mark with this processor. It has TrustZone support. It has a 8 kilobyte two-way set associative cache, 1 mega flash, and a half mega of RAM. The network processor is fully programmable, optimized for efficiency, and it's locked to the 64 MHz clock speed. It has a 2 kilobyte instruction cache, and a 256K flash, and 64K RAM. Then we have this graph showing performance in core mark on the y-axis and efficiency in core mark per milliamps on the x-axis. So at the bottom left you have the nRF5340, running at 64 MHz, and this is capable of doing 212 core mark and 64 core mark per milliamp. And then up here you have the application processor in the 5340 running at full speed, 128 MHz. Then you get 510 core mark, so you get more than double that you get on the 52840, and actually it has better efficiency, as you can see. Then you have the application processor running at 64 MHz. Then you get 255 core mark, still better than the 840, and significantly better efficiency. And the frequency of this application core can actually be changed at runtime. So typically you would run at 64 MHz, but if a specific task needs more performance, it can be changed to 128 MHz and then back again. On the 64 MHz network core, we have passed the 100 core mark per milliamp mark, still having higher performance than nRF52840. There's a massive improvement in efficiency on this one. Then we have the power and clock system. It supports the extended supply voltage up to 5.5 volt, so that you can power it with rechargeable batteries or a USB. You have LDO and DC-DC options. It will run most efficiently using the DC-DC, but then you need a couple of more components outside the chip. Or you can go for LDO if efficiency isn't that important. You can power it directly from USB, and then you are using the 5 volt VBus signal, which is always available when you are connecting to a USB host. When it comes to the oscillators, you need to have a 32 MHz crystal, and then optionally a 32 kHz crystal. But on both of these, you have integrated the load capacitors, reducing your bill of materials. We've also added a tunable on-chip audio PLL. So on the nRF52 series, we run the PDM and I2S audio interfaces on the 32 MHz clock. But this doesn't always give the best quality. So we decided to add this audio PLL, and this can be used as a clock source when using I2S and PDM audio interfaces. It has low jitter and will give good quality, so it's suitable for audio applications. We also reduce the external components, as I mentioned, so you can save two components if you're only using the 32 MHz crystal, but if you're also adding the 32 kHz crystal, you are actually saving 4 components compared to the nRF52 series. The DPPI is a new peripheral. It's distributed programmable peripheral interconnect, and this replaces the PPI in the nRF52 series. So it offers a new interconnect interface for peripherals. And in the nRF52 series, you had a PPI 1-to-1 channel, and you could also do 1-to-2 with PPI fork. But now we can do 1-to-1, 1-to-many, many-to-1, and many-to-many. It is a new interconnect paradigm. And it works in a way where the task subscribes to a channel and an event publishes to a channel. So the CPU cache on the application processor is connected to both the internal flash, as you can see here, and also optionally an external flash through the quad SPI. And the Quad SPI interface have gotten quite a few improvements compared to the 52 series or the nRF5340, where the maximum frequency was 32 MHz. It also has low power mode, and a very interesting thing is that it can do on-the-fly encryption and decryption. This is very useful if you are afraid of attackers reading out sensitive data from the external flash. So with this system, you would encrypt the data and put it on the flash, and then it is unreadable. Then the nRF5340 can decrypt on the fly when you need the data. It can also write encrypted data into the flash. Communication between the cores. So I already mentioned the IPC, the inter-processor communication. This only generates events and can be used as can wake up the other processor or trigger a specific function. And then if you want to do memory and peripheral access, you use the AMLE bridge for that. And this could be a bit complex to set up, but we have abstracted that complexity away by adding a software framework for this, and this is the Open AMP, which is part of the nRF Connect SDK. Okay, software support. So we offer the nRF Connect SDK, and this is the software development kit for nRF5340 and nRF9160. So it's a common platform for cellular IoT and short-range wireless development. It integrates the Zephyr RTOS, and it's publicly hosted on GitHub. Version control management is offered with Git, and you get Segger Embedded Studio IDE support for free. So this is the setup that you have for nRF Connect SDK on the nRF5340. So we have a Nordic Bluetooth Low Energy controller, or a link layer, as some of you know it, and this is available as a library. This is the same as the one used in our soft devices. And then we also provide a multi-protocol block here and a coexistence interface, and these are also libraries that has IP that we want to protect. And then all the things in pink or purple here is inherited from the Zephyr repo. So you have a Zephyr Bluetooth Low Energy controller as well, and this is contributed by us. And then you use either of these controllers together with the Zephyr Bluetooth Low Energy host. And this offers very good integration with the Zephyr RTOS and the kernel there, and also reduces the complexity in the API. You also have the MCU bootloader and the kernel and the board and device config from Zephyr. Then you develop your application on top of this. And Nordic will contribute, test and certify the complete Bluetooth Low Energy stack. So you will have QDIDs for product listings, will work the same way as with the soft devices. So here I just want to show you the very flexible software architecture that we have. So you see the application core on top, and then a network core at the bottom, and then you have the interface between them, which is this Open AMP that I mentioned earlier. So you can, not all of these setups will be available right off the bat, but this is the typical setup where you have the protocol stack running in the network core, and then you have an API, and you have the user application in the application core. But there are situations where you want to split this. Maybe you want to have the low-level protocol stack in a network core and the high-level protocol stack in the application core. This might be maybe if you're using Thread, you want to have everything that is controlling the radio in the network core, but then you have an IP stack and also IP security and so on that maybe you want to run in the application core. This means that you can have space left. You can also have space left in this situation for some of your user application, so that you can have pieces of code that you put in a network core that you run very efficiently. And then you have the rest in the application core. You can also have this setup where you have two protocol stacks in a network core. And this would typically what you want to do if you want to have concurrent multi-protocol. You need to have two stacks in there. And you can also split one of these, of course, to do a setup like this with low level and high level. And yeah, it's very flexible. So with the Bluetooth Low Energy samples that we have in the nRF Connect SDK today, this is the typical setup. So in the application core, you have the Bluetooth LE sample, which can be from nRF Connect SDK or from Zephyr. And you have a Zephyr Bluetooth Low Energy stack, higher level protocol stack here. And then you have HCI over OpenEMP or host control. That's a host controller interface. And this is where you communicate between the processors. And in the network core, you have either Nordic or Zephyr Bluetooth Low Energy controller or link layer. Security is important for us and our customers, but it's also very complex. But we try to provide you with the tools and building blocks to make a secure product. So we have Arm TrustZone, and this provides a system-wide hardware separation for trusted software by creating secure and non-secure regions on a single core. So trusted software can be secure boot firmware or other sensitive firmware, and you can keep this away, separate this from the non-secure firmware. It could also be secure data or services. This was introduced with the Arm v8 instruction set architecture, and it has been supported by their Cortex A series for quite a while. So it's proven, it works. And with V8, support was added to the M series. So M33, M23, and M35. And it adds this some special instructions for calling secure code, and it works in thread mode and in handler mode. It offers flexible debug access, so the debugger can have access to everything or only the non-secure. So this means that if you have some firmware that you want to protect from the debugger, you can configure that. So we have one peripheral that is related to TrustZone, and that is the System Protection Unit, the SPU. And this divides the memory into secure, non-secure, and non-secure callable. And the peripherals can be either always secure, always non-secure, or configurable. So there are some peripherals like the CryptoCell, the System Protection Unit, the Key Management Unit, and the UICR. These are always secure, and this is actually a requirement for some of the security certifications that is out there, like for example PSA from Arm. While the GPIOs, the non-volatile memory controller, and the DPPI are split, because they have several pins, GPIOs or channels. So you need to have internally configure which one should be secure and which should be non-secure. The key management unit, this is secure key storage. It has 128 key slots, 128-bit keys, but you can combine key slots for larger keys. Offers OTP emulation, and here key memory is so this OTP, that's not OTP, but it's a separate flash page that can't be accessed by the CPU. So you write to the QEMU over the APB, and then you disable the read, and then you have this push function. So we can say push, and then a key is transferred over to the CryptoCell over the secure APB. And if a key is compromised, it can be removed. And what you typically do is that you have several keys that you program in production, so that you are able to switch to another key if one of the keys is compromised. We have the CryptoCell 312 upgrade from 310. It offers stronger encryption, and this 256-bit AES is actually often a requirement in end-to-end encryption in IoT applications. You can do cryptographic operations in Flash, run them in Flash, resulting in performance improvements. And when it comes to the features, this is used as a cryptographic backend to embed TLS. With embed TLS, you can have a software backend or hardware accelerated backend. So be sure to use the CryptoCell if you're using embed TLS. We have a FIPS 142 certified random number generator. The CryptoCell can also be used for firmware image validation when doing device firmware update. And also together with the key management unit, it can implement a hardware root of trust. We also have security software support. And this is several pieces. So at the bottom you have the immutable bootloader. This is not changeable or upgradable. So after you have flashed it, it cannot be changed. And it's the first thing that is executed at boot, and then it will lock itself down and validate the secure bootloader, here called MC boot. And this is the secure boot of the system. It can be upgraded over the air. And then MCU boot validates the secure image. And there you have the secure partitioning manager that configures the secure and non-secure regions by using the system protection unit. It also contains the cryptographic toolbox to interact with the CryptoCell. The non-secure callable region here is where you do function calls to access the secure region from the non-secure. Development tools. So we have a nRF5340 PDK. This stands for Preview Development Kit. It's very similar to nRF52833, nRF52840 development kits. It's Arduino Uno Rev 3 compatible. It has antennas for 2.4 GHz and NFC. Comes with a Seger J-Link onboard programmer debugger. All IOs and interfaces are available via connectors. It has LEDs and buttons, dedicated pins for measuring power consumption, and SVF connector for direct RF measurements here. You can supply it from USB, external supply, LiPo battery, or coin cell battery on the back. It's important to note that this will be replaced by a nRF5340 DK when the nRF5340 SoC is closer to being production ready. On the tool side, we have a programmer app, and this is a cross-platform programming and memory visualization tool so that you can see the network core and application core in there. It visualizes the firmware and the memory layout before you write it. You can also read out the memory, and this is an app in the nRF Connect for desktop tool. Initially, this device will come in one package, 7x7mm. It's an AQFN94 package with 48 GPIOs. As I mentioned, it will always we will also come with a CSP package. Details on that later. So we offer the complete development solution. You have the nRF5340 SoC, multi-core flexibility, truly secure, all in one. We have the nRF Connect suite of tools and software, nRF Connect SDK, nRF Connect for desktop, cloud, and mobile, which all supports the 5340, and you have the preview development kit for the nRF5340 SoC, making all the features of the nRF5340 SoC available to the developer. That's all I had, so then it's time for questions. Okay, then we have some questions here. Is it possible to use the IEEE 802.15.4 protocol or thread and BLE at the same time? Yes, this is possible. We don't have support for that right now, but that is something that is coming. Will there be new SDK versions of nRF5 SDK, or will it be completely replaced by the nRF Connect SDK? So the nRF5340 will only be supported by the nRF Connect SDK. There will be no nRF5 SDK support for the 5340. What is the maximum transmission power and what is the maximum MTU size? Maximum transmission power is 3 dBm. And maximum MTU size when using Bluetooth Low Energy is 512. Why practice with soft device gone away? Is the reason for Separatos that it supports TrustZone, etc. So we have been very successful using the soft device approach. But as many of you know, these soft devices are growing with all the features that are coming in Bluetooth Low Energy. So with this new approach, it's actually possible to tune the stack according to which features that you actually need, so that you get the memory footprint that is according to the features that you actually need. Does the nRF5340 integrate a balloon filter? Yes, it does. Can direction finding be used in ESB, enhanced shock burst? The radio is capable of doing direction finding, so you can do that in a proprietary way if you want to. You can do it in Bluetooth Low Energy, so you can do it in a proprietary way as well. We already have companies doing that in a non-proprietary or in non-Bluetooth Low Energy way. It's a company called Coupa, for example, that is doing that. What hardware and software is available now to try direction finding, angle of arrival, angle of departure? Hardware is already available, but we are working on the software. How about edge computing, artificial intelligence, machine learning on the edge? That is definitely possible to do in the 5340. There are people already doing that in the 52 series, so it only depends on how advanced the models are, how much memory they require. Will the 5340 support Bluetooth 5.2 features such as audio over BLE, isochronous channels? It will definitely support those features that's coming. Will you recommend the 5340 device over 52840 for all new designs? That really depends on the design, what requirements you need, how much memory you need, and the features. The 5340 is a very capable device, but in some use cases, the 52840 can definitely do the job. Does it support USB host? It's only a USB device. And then let's see here. Since the nRF Connect SDK can run on the network core independent of the app CPU, can we use a different OS on the application core? That is possible. If you're making a Bluetooth Low Energy example, you can take an image from nRF Connect SDK and place that in the network core. And then you can implement your own or use whatever you want in the application core and combine them over the IPS interface. The app core clock 6428 MHz can be dynamically changed on runtime. Yes, it can. I mentioned that in the presentation. When can we plan on going into production with the 5340 and what will be the pricing? This is at the moment confidential information. So if you want to know when it goes into production and some guidance on the pricing, I suggest you contact regional sales managers for your area. What is the size of the full function stack? This is the soft device size can give you a guidance there, but as I mentioned, you will be able to tune the size of the stack depending on what features you need. So if you want a very simple peripheral stack, for example, you will have a very small stack. On the network stack, do we have to choose between Zephyr LE controller and Nordics? You have to choose one of them. Yes. What is the flash retention at 105 degrees Celsius? That is not public yet, but it's 10 years at 40 degrees. That will be something that is available when we go into production and we release the full product specification. Why is the initial BLE examples only running in the controller in the network core? That seems like a waste of resources. This is just an initial example, but we will provide examples offering much more flexibility on this later. What is the idle current consumption with full RAM retention in both cores? I don't have that number in front of me, but if you on the network core, it's 1.8 microamps on system on with 64K RAM retained. But you should be able to calculate that number if you look in the OPS. Then there's a question: are all GPIOs 5-volt tolerant? No, it's the same as in the 52840, 1.7 to 3.6 volt. Is it possible to supply other components, sensors on the board from the nRF53? Yes, that is possible. It's similar to the 52840. Look for more information in the OPS. Which of the two cores starts first, or they both start independent? So typically, or the application core starts first, and then it can wake up the network core if necessary. With the built-in crystal capacitors, how do you tune the oscillation frequency? So you can tune that by, they're tunable by registers, so that you can get a match there. Will future direction finding software examples be integrated into Zephyr? Yes, that will be part of the NCS or nRF Connect SDK. Do you know when Zephyr will support Red? That I don't have anything on. with USB missing on the PDK, is it broken in the current silicon, or can it be added manually? This will be something that is added when we release the DK, the development kit with silicon that is closer to production, that will contain USB peripheral as well. Yeah, I think that is what I have time for today. I hope you enjoyed the webinar, and if you have any more questions, please use DevZone, and we will try to answer you there, or if you weren't happy with the answer I gave. A recording of this webinar will be available, so you can watch it again, and also the presentation will be available. Thank you for watching.